Okay, what happened first? What happened next? Was there anything in between that we left out? What happened after that? It's very much like a sequence of numbers. What number comes first? What number comes second? What number comes third? Is there any relationship between how this sequence is going down? Is there anything that caused the third term to occur or to happen or to come about from the second or from the first? So sequence of events is kind of an easy way of just thinking about, okay, we're thinking about first and second and third. But with first and second and third, we're talking about, in general, this guy named A sub n, usually for n equals 1, 2, 3, etc. Which makes it a little bit weird and makes it that your calculators need to change modes, because function mode says, oh, x is equal to, well, in Zoom standard, do you guys remember what your x min and x max are in Zoom standard? Negative 10 to 10, right? So what x's get plugged into your functions to be graphed? Just negative 10, negative 9, negative 8, negative 7, negative 6? Or do more x's get plugged in than that? Yeah, because if you guys notice, let's just do a really basic example. Let's say we were to do something like, I don't know, f of x, function mode. Don't worry about your calculator, just think with me. What if I was to do something, what's something super basic? How about like 2x plus 1? Is that good? Okay, and let's say we were Zoom standard. So we had like negative 10 over here. We had positive 10 over here. Your calculator is kind of like a squished triangle, so it's going to look a little bit off, which is why we sometimes use Zoom square to make it all nice. But let's just say it's Zoom standard. How would this be graphed, guys? 1 up on the y-axis, right? And then up 2, right, over 1. So it's going to be kind of steep. Is that okay? Down 2, left 1. Okay, it's going to be a kind of steep line. So how much are you really going to see? Well, not much, because remember, your window's going to stop, right? But either way, you're going to see a point for 0. You're going to see a point for 1. You're going to see a point for 2. You're going to see a point for quite a few guys, right? 3? I guess there should be more than that, huh? Because 1 would be 5. 2 would be, no, 1 would be 3. 2 would be 5. 3 would be 7, 4 would be 9. So it should have gone up to 4. We'll throw one more little guy in there. 1, 2, 3, 4-ish. Okay. But guys, is it graphing just at 0, at 1, at 2, at 3, at 4? No. It's graphing everything in between. So when we're talking about what it's graphing on like a Zoom standard in function mode, that's the one that you guys just got out of, right? It's graphing all x within negative 10 to 10. Now, if the window's too small, it can't show you all of them, but it's showing all. So question, if you were to go in your calculator in function mode and find the value when x equals 1.5, would there be something? Yeah. How about if you were doing the value at 2.999? Yes. Why? Because function mode says all x is in between. But when I talk about sequences, can there be a 1.1th event? What happened first? What happened 1.1th? We don't say that. Don't we say what happened first, what happened second, what happened third, right? What is the first term? What is the second term? What is the third term, right? So in sequence mode, it's going to look weird. Can you guys go ahead and, we'll talk about this a little bit more, but can you guys go ahead and put in this example? I think it's on the next page. Oh, let's get rid of that one. This one. Do you guys see the formula? A sub n is equal to 3n minus 2. Wait, have you played around in your y equals? Things look weird, right? Do you see a's? No. What do you see? Bless you. U's. Okay, no big deal. So when you're in your graphing calculator, and when you see a u of n, you see it? Then we can rewrite this and say, okay, the book is saying a sub n. That is a very common way of doing it, but whoever programmed said u. Okay, whatever, fine. So we could rewrite this to be u of n is equal to 3n minus 2. Wait, how do we get n's? Did you guys figure it out yet? Yeah, it's one of the variable options. So have you guys wondered why it's x comma theta comma t comma, wait, which one's next? X comma t comma theta comma n, right? It's x sometimes, but it's n sometimes. Well, guess what the t and the theta stands for? Go back to your modes. Are there two modes in between function and sequence? Hey, guess what? Par goes to t and pol goes to theta. And we'll see all of them before the year is out. Oh, that's cool. But for right now, the x button is an n. Okay, cool. That's easy, right? So 3n minus 2. Try to go graph it. Is it working? Yeah. Did you guys notice there was something before the u of n? Wasn't there something called n min? What did you make n min? Sometimes it could be 0, but in this case, they are saying start at 1. And you might be like, 0, why would you start at 0? It's what happens first, second, third. That made sense with the sequence of events. Have we talked this year all about physics? Yeah, okay. And talked about x's being like t's for time? A little bit. What would time equal at the beginning of a situation? 0 time has passed. So even though we could say what happened first, and that's one way of saying it, we could say what happens when t is 0. So there might be times where they want to start at 0 instead of starting at 1. But either way, this case, this one says start at 1. We're like, okay, fine. Is there anything else that you guys saw that looked like needed filling in when you guys were doing the y equals in sequence mode? Yeah, there are two u's under it. What are those u's labeled? U1, U2? Okay. Sometimes, depending on the sequence, and we'll see one, I think, before the end of this section, but probably tomorrow. Sometimes in sequences, we don't exactly have this nice, pretty formula where it's like, give me n and I'll give you terms. Sometimes it's a formula that just shows a pattern instead and says, hey, give me this, and then put them together this way, and I'll get you the next term. And then give me this and this, put them together, and I'll get you the next term. If you've ever heard of Fibonacci sequence, that's really similar to what I'm talking about. We'll see Fibonacci before the end of the section. But sometimes, in order to get a future term, you need the first few. But for us right now, we actually don't even need those. So did you guys try to graph without filling those in? Okay, what happened? Yeah, what's the graph look like? When x is 1, oh wait, it's not x anymore. It's technically n, right? When n is 1, what did it put? It put 1? So it had a point at 1, 1. Is that what you mean? Yeah. Okay. How about when x is 2? Or I should say when n is 2? 4. But what was weird in sequence mode that didn't happen in function mode? It wasn't connected. Do you see it? It's not connected. This is what we call, and there are a few different ways of saying it, but this is called a discrete function. I don't even think the book makes you need to know this, but it's called a discrete function instead of a continuous function because it's not connecting everything continuously. It's not moving continuously. It's saying, hey, what's going on at 1? What's going on at 2? What's going on at 3? It's going to show you what we would call a dot plot. Kind of like a scatter plot. Because sequences are only defined for positive integers. Joe, go ahead. What's up, Ben?
So there's no number
No. Because if you think about n as being...
second term, but there's no like 1.5.
Exactly. Exactly. And that kind of makes sense if you think of a sequence of events. First, second, third, not first and a half. Second and a third. No, that's not a thing. So, sequences are defined with positive integers, and those positive integers in some way, shape, or form can actually be plugged in to get terms. There can be formulas that give us the terms. There might be patterns to the terms. But ultimately, those n's stand for the placement in the sequence. Now, remember, sometimes it can start at 0, sometimes it can start at 1. If they wanted, they could have you start somewhere totally different for another purpose, for another reason. But for us, a sub n is going to be a formula for the nth term in our calculator. going to be u of n. There are other ones though, right? In function mode, isn't there y1, y2, y3, y4? But in sequence mode, it's different. It's u of n. What comes next? V of n. Do you guys keep scrolling down? Can you do more than 2?
Yeah.
Is it w of n next? So they're just using letters that we don't normally use somewhere else. I think that's the only reason they're really doing that. Can you guys see? Wasn't there a place in our calculator where we could go find y's, like to plug in stuff, like y1 of, and we could use the y1s? Do you guys see anywhere where there's a little lowercase u in your calculator? And the nice thing is you don't have to go looking in menus. Look on the actual buttons or look above the actual buttons. You see any lowercase u's or lowercase v's? Yeah. Oh, Tyler found it. Where? 7 and 8, yeah. Is it second or is it alpha? Second. So second, 7, or second 8. If you need to find the little u's or v's, you can do second 7 or second 8 and find the little u's and the little v's. And we're actually going to use those a couple times at some point during the chapter. Now, this chapter isn't one where you really have to be an expert at your calculator, not like last chapter with matrices. But it is nice to kind of know what's going on and to get a picture if you need to, or to be able to plug stuff in, etc. I think we got it. We got our domain. Already talked about that. Already talked about n starting at 0 or 1. So what we didn't do was plug in. But guys, well, isn't this one kind of easy to plug in anyway? Did we actually need our calculator for this? No. Probably not. Because if you plug in 1, you get, we already talked about it, 1. If you plug in 2, you get 4. If you plug in 3, bless you, 7. It's okay. Joe was in a different dimension for a second. So 1 and then 4 and then 7?
10.
Ah! There's a pattern! Is that how you guys got there? Or did you actually plug it in? Why is there a pattern? If we look at this formula really closely, can anyone see how, just from the formula, without actually plugging in, maybe we could have seen that you're just adding 3 every time? How? The minus 2 is always the same. The 3n is what changes. So at the very beginning, you have 1 3 that goes in. The next term, you have 2 3s. The next term, you have 3 3s. Isn't 3n actually talking about how many 3s you're going to have before you subtract the 2? Does that make sense? So if there's only 1, no big deal. If there's 2, there's another one. If there's 3, there's another one. If there's 4, there's another one. You see it? So what's one way? Plug in, plug in, plug in. What's another way? Plus 3, plus 3, plus 3. Which one seems easier? Yeah, so if I wanted you to find a sub 5, you could be like, all right, fine, I'll go plug it in. Or you could say, it's easy, it's 13, right? If we can find the pattern, we'll be set. We'll be golden if they just want like the next term or the next 2 terms, the next 3 terms. But here's the problem. If we only know the pattern, what if they want the 100th term? I think we might want to think formulas instead of patterns. Does that make sense? So if I say, what's the 6th term? Most of you were like, no big deal, add 3. If I say, what's the 100th term? You're like, I'm not jumping to 100. I'm going to come plug them in up here. And I'm going to say 300 minus 2 is 298. Ah, done. Pattern people would have been like, uh-oh, plus 3, plus 3, plus 3. Uh-oh, how many did I just, I don't know, right? And now a computer, if you could program it, you could get to the 100th term pretty quickly. But we're not necessarily computers, are we? Are patterns nice? Yes. Are they enough? No. So how do we define sequences? 2 ways. How do we define them? Or how can we be given them? Do you guys see what's up here? Formula is given or the sequence is given. If we're supposed to be figuring out a formula or working with a formula, specifically for the nth term, this is snazzy vocab for a sub n. Nth term is a sub n. Give the formula to us, but they can actually give the formula 2 different ways. One way is super basic, like we already saw. And a sub n just says, hey, plug in whatever n you want. If you want the first one, plug in 1. If you want the 10th one, plug in 10. If you want the 100th one, plug in 100. No big deal. But there's another kind of formula that we're going to talk about a little bit more. that usually the book shows with a different letter, not because it means anything different, but it shows that it's actually being found a different way. And we could do something like, now when you start seeing things like this, it starts to get kind of nasty, kind of weird. But the meaning really isn't that hard. Let's say I wanted a sub 100. The a sub n says, give me 100, I got it for you. The a sub k says, give me 100, and I need the, what's 100 minus 1? I need the 99th to get it for you. Oh, well, stink. Well, how do you get the 99th? Oh, no big deal. To get the 99th, all you need is the 90. Oh, this is the pattern. These types of formulas show you the pattern. They say, if you could just tell me the term before, I got you. I got you covered. If you know the term before, just times 2. It's like the last example. If you give me the term before, just add 3. It's easy. This one just shows the pattern. This one lets you jump straight to the term. But guys, these are two very different ways of dealing with them, which means that their formulas could look very different as well. So there are 2 different formulas that might be given, or I should say 2 different types. There are actually names to these. We'll talk about them more in a bit. The pattern is super nice if you're able to use technology and write like computer programs, etc. Because a computer can do a pattern, can do repeated addition, multiplication, or even just patterns really fast, really quickly for really high numbers. But brains can't necessarily do that. So for our purposes, it might be way easier to use this type of formula if we can find it. Maybe it's given to us, maybe we have to find it. And this one, well, if it's good for computer programming, it might be good for us to learn what that's saying as well. Or they could, instead of giving us one of these 2 types of formulas, they could just actually give you the sequence and say, okay, here's an A1, here's an A2, here's an A3. And then they say, from this, now tell me what A sub 10 is. And you're like, I don't know. Well, you better find a pattern. From this, tell me what the pattern is. Well, I don't know. Well, you have to look and see how they're related. But they could give you formulas or they could give you sequences. So this way, or this one, how is it given to you? Yep, the sequence. What are you supposed to be doing? Maybe find the pattern. Maybe just find the formula. Because the pattern is that A sub k. This one's an A sub n. They're kind of asking for, give me an n and I'll give you a number. Wait, maybe we should think about our n's then. What do we say that n usually starts with?
N1.
Yeah, n usually starts with 1. So we can say this is A sub 1, aka when n equals 1. I need some formula such that I plug in 1, I get 0. You're like, oh, that's easy, n minus 1. Ha-ha! Well, doesn't this work for the first term?
It doesn't work for a second.
Oh, it doesn't. It doesn't even work for the first term, does it? Oh, yeah, it does. Because 1 minus 1 is 0. It works for the first term. But Joe just said it doesn't work for the second, because the second is when n equals 2. And guys, what happens if we plug 2 in? 2 minus 1 is not 3. Okay, well, what's another way of getting 0 from 1? Maybe we should ask ourselves, what's a way of getting 3 from 2? Oh, that's easy. N plus 1. No, 1 plus 1 would be 2. That doesn't work. Maybe we have to go beyond addition and subtraction? What if we did 2n minus 1? What's 2 times 1 minus 1?
2n minus 2.
2n minus 2? It works for the first one. 2 times 1 minus 2 is 0. 2 times 2 is 4 minus 2 is 2. I'm closer. How about 3n minus 3? Ha 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 ha. Why not? 3 minus 3 is 0. 6 minus 3 is 3. Ha! 3. 9 minus 3 is 6. But do you guys see what do you see what I'm doing? But do you see what I'm doing? So we need a 1 to get 0, a 2 to get 3, a 3 to get 8, a 4 to get 15, and a 5 to get 24. Man, I've tried adding and subtracting. I've tried multiplying and then adding and subtracting. Dividing, well, I don't know if that's going to get us the big numbers. Maybe we should be thinking, instead of adding and subtracting, multiplying and dividing, how do we get one operation harder than that? Squaring? Oh. 1 squared is 1 minus 1. 2 squared is 4 minus 1. 3 squared is 9 minus 1. 4 squared is 16 minus 1. 5 squared, look at that. But what did I start off with? The easier stuff, adding and subtracting. And I was like, I made it work. It doesn't work. Oh, well. I made it work. It doesn't work. Well, I made it work. It doesn't work. Oh. I'm going to write this off to the side to give you a little bit of hope. This is section what again? 9 point. It's the first section. That was kind of hard. Section 9.1 is an introduction to a huge topic that you are not going to fully learn this year. Kind of like vectors. And you're like, oh, we learned a lot of vectors. Okay, we did. But there's a whole chapter 11 that deals with three-dimensional vectors. That's really helpful for physics, but we're not going to do this year because we don't have time. And we're not pre-physics. We're technically pre-calculus. So we're going to chapter 12 instead of chapter 11. But anyway. This whole thing with sequences and series, do you guys have any idea what class does a lot of this work? A little baby bit in stats. Personal finance, not really. Keep thinking. Which one? BC. Calculus level 2, sequences and series come back. So you're just being introduced. So section 9.1 is like, hey, there's a thing called sequences and series. And we're not going to really tell you much, just kind of play with them. Guys, trial and error playing with them. It's not something you're supposed to be able to like, ooh, I have a genius brain and I just come up with these formulas in 2 seconds flat. No. If you see this direction in homework, you're just playing with it and seeing if you can make it work. It's not something where you're like, I'm a failure at life. If you can't figure out the a sub n formula, Calculus BC kids struggle with finding the a sub n formula, and they've had to practice it for the last 2 months. Don't worry, they're doing way more than that. They're not just sitting there trying to think of formulas. But, in section 9.2, don't worry, the book says, okay, we introduced you to this huge topic. Let's just talk about these ones called arithmetic ones. 9.3 says, okay, there's this huge topic. Let's just talk about the special ones called geometric ones. And as soon as we talk about these special ones in section 9.2 and 9.3, they have actual formulas that go with them that we can memorize and not need to stress about. Now, if you have any friends in Algebra 2, did they do sequences and series recently? Have you guys talked to them? Oh, talk to your friends in Algebra 2. Did you hear how they didn't have Pi Day last week?
Yeah, that was great.
Why didn't they have Pi Day last week?
Because they don't deserve it.
Well, you can ask Mr. Che what the full reason was, if it's any different. But he graded a quiz, and that quiz went really, really bad for almost all of them, if not all of them. And they had to do corrections on Pi Day instead of Luna's shaking her head because she was the one that told me about it. Pi Day got canceled because they did so bad on a quiz about sequences and series. Why? They didn't memorize their formulas. It's tricky, but they didn't memorize their formulas, so they weren't ready. They underestimated it, which you guys hopefully won't do, but pause once again. This section is just an introduction to the whole chapter, okay? Just an introduction, so some things are going to feel weird, like this. Just play around with it, see how you can do. But we have more to do. Matthew, is it on this one? This, okay, go ahead. Ooh. Matthew is thinking about how there were 2 different ways of defining. This one was really hard to get, and he was like, I wonder if it would have been, I think this is what you're thinking, would it have been easier to go this way? Is there a pattern between the terms? Not like how to plug in 1, plug in 2, plug in 3, that was this, but how to go from here to here. Do you guys see any pattern that was actually cleaner and nicer than this? You add what? And then you add, and then you add, and then you add. The pattern was easier than the nth term formula. But the way to write it is kind of hard. So see if you can see how I write. Ready? We're starting at 0. And we're adding 2 the previous term. Actually, I could go ahead and say, because 0 is just the very beginning, I could just say a sub k minus 1. We're adding to the previous term an odd number such that a1 is equal to, remember how in your calculators there was the u1, u2 thing? Okay, check it. I'm saying, where does the whole thing start? 0. And so, to get the, well, you know the first term, so what's the next term you would try to get? If you know the first, what's the next term you would? The second. So to find the second term, a sub 2, I would take a sub 2 minus 1 as a sub 1, right? To get the second term, I would take the first term, who's who? 0. And then I would add in 2 times 1 is 2 plus 1 is 5. Ah, stink. I don't want that. I want 3. So let's do 2k minus 1. Does that work? Now try. To get the second term, take the first term, 0, and add 2 times 2 is 4 minus 1 is 3. 0 plus 3 is 3. How do I get to the third term? I take the second term, 3, and I add 2 times 3 is 6. 6 minus 1 is 5. To get an odd number, you can always do 2k plus 1 or minus 1. To get an even number, you can always do 2k. 2 times 1, 2 times 2, 2 times 3 are all the evens. To get odds, you can take away 1 if you want to go down from that, or add 1 to go up from that. But Matthew, this is a way, and this technically is a formula for this sequence. The problem is, if you were doing this like in your brain, if I asked you for the 100th term, you would know what was added, but you wouldn't know what the term before would have been unless you did the whole sequence to get up to that. Does that make sense? Oh, because I've done a lot of sequences in series in the last few years, and whenever you want an even number, like an expression that gives you evens, like 2 and 4 and 6 and 8, you always do 2 times k. And whenever you want an odd, you always take an even and you either add or subtract 1, or add or subtract 3, or add or subtract 5. So what I did is I said, well, I'm finding the second term, 2 times 2, because k is 2, 4, and I'm like, ooh, plus 1? I don't want to add 5, I want to add 3, so I went minus 1. Does that kind of make sense? Boop. Hey, speaking of a sub k, great lead-in, Matthew, thank you. Those are called recursive. We didn't talk about the vocab to it yet. Speaking of a sub k's and the patterns and trying to figure out the patterns, those are called recursive. In programming, computer programming, if any of you ever go into that, there's a recursive type of programming recursively. It's making the computer do repeated tasks, do a task built on the previous result. Recursive, you probably don't really see that word anywhere else, at least not in high school. I'm saying in high school because there are some high schools that offer like AP Computer Programming or AP Computer Science. We are offering AP Computer Principles next year, which gives you kind of like a general, broad overview of the programming languages. I think the teacher gets to choose whatever programming language they want to show you. There are lots out there. There's another AP in Computer Science that we don't offer here. We used to a long time ago. But that one was specifically with Java, maybe a little bit of C++. Anyway, so some high schoolers might know recursive. Or if you do, you guys know you're not necessarily limited to only being able to learn what Heritage Christian offers to teach you, right?
Yeah.
You know, you can be like interested and passionate about something and just go search it out on your own. And there's so many different things. Khan Academy is only one option, but different places where you can learn. Computer programming especially is something that you can play around with and get a really good handle on. Colleges love that too, to be like, oh, you liked this, your school didn't offer it, but you still went after it? That's awesome. Just some of you guys are sophomores, juniors. They love that kind of thing because it shows that you're interested, you're passionate, and you're not going to be held back by limited opportunities. You're going to make your own opportunities. Anyway, that also has to do with, well, now we have a robotics club, but we had some kids in past years before we had a robotics club that were out doing robotics competitions with different like local organizations, etc. Got them into nice schools also. Recursive sequence, what's going on?
Depends on the previous one.
Yeah. And you guys kind of saw that here, right? This one says, give me anything. Give me 100. And I'll tell you the 100th term. This one says, give me 100. I need the 99th. Oh. But I'll tell you what the pattern was to get from the 99th to the 100th. You're like, great, but I still need the 99th. To get that, I need the 98th. And to get the 98th, I need the 97th. Ugh. So sometimes it's gross, but with computers, it's easy because they can just take a pattern and run with it, especially if this formula is sometimes really complicated to find. So what's pros? Pros is all you need to figure out, well, all you need to figure out. You need to figure out the pattern, and then you need to take the pattern and put it into math, which is sometimes really easy. Let me show you an example of where the pattern into math is really, really easy. Didn't we do one a second ago that was really, really easy? I didn't show you guys the a sub k formula for this, but guys, what was the pattern and why was it so easy? What was the pattern every single time? So I could say a sub k is equal to a sub k minus 1 plus 3. Look how easy that was. If I solve 4, 7, 10, 13, I'm like, easy cheesy to find this, like the previous term, add 3. Oh, wait, I have to say where to start. I have to say start at 1, because if you start at 2, it would be a totally different sequence. If you start at 3, it would be a totally different sequence. But this pattern's easy, plus 3. But how is this pattern that Matthew had me think about? I mean, the pattern's not hard. If I asked you guys for the next term, could some of you guys have realized you're just adding 11? Like, doing the pattern's not hard, but writing it mathematically, it can get kind of tricky unless you learn things like how to express odds, how to express evens. Oh, I went way too far, sorry. So, pros, I would say pros, you need to do a pattern or find the pattern, but maybe we should make the whole, oh, that just got really weird really fast. There we go. Maybe the con is that you have to put the pattern into math expressions. You have to somehow put it in like a formula. That's kind of a bummer. Pros is that if you find the pattern, you can find terms with low end values or with low ends. Like, you give me the first 4, I can find the 5th and the 6th and the 7th really fast. I'll just keep doing the pattern. But the cons, there'll be a lot of number crunching and a lot of work to find terms with high ends. Like I was saying, give me the 100th. And you're like, well, I don't know. You have to keep on adding until you get to the 100th. Well, yeah, that stinks. Unless you have special ones, like 9-2, say, oh, but there's a pattern to the pattern. Well. So guys, check out this example. Oh, something's weird. Sorry, something's really weird. Did you guys notice that I was using like an operation, it's an equation editor. It wasn't letting me do -1. Yeah, put a little k minus 1. Let me do like a subscript, but didn't let me do like multiple subscripts. Sorry. So a sub k is equal to -2 a sub k minus 1, where a sub 1 starts at 14. So the question, if a sub 1 is 14, if that's our starting point, and if the recursive formula shows the pattern, my question for you is, if we need to find all the other terms, eventually we need a sub 2, 3, 4, and 5. I just am curious, do you know a sub 2? What's a sub 2? You guys agree with Joe? Is it just -2 times that term? Because to get a term, we look at the previous term and we do the pattern. So the pattern says times -2. So what's -2 times 14? See, it's not bad if you know what you're looking at. If you don't know what you're looking at, oh my goodness, it's ridiculous. But it just says, take the previous term times -2. Cool. So to get him, take the previous term and do what? 56. Let's see how well your mental math is. This one, take the previous term and do what? Which is -112. You can think doubling 50 is 100, doubling 6 is 12, 112. A sub 5, all I have to do is take a sub 4 and do what? Which is going to be 224. Positive, right? So what's the most famous recursive sequence? Oh, look, now's the time. Who is Fibonacci? Who's Fibonacci? Fibonacci? Is he French? Is he Italian? I don't know. But whatever he is, he's European, true? And he is credited, or at least his name is credited, for the Fibonacci sequence. Had something to do about the reproductive nature of rabbits. Anybody know that rabbits reproduce really fast? Because they come to maturity really quickly? There you go. Fibonacci. Okay. If you have one bunny, this is going to be confusing. Maybe we won't do it the bunny way. The bunny way gets a little complicated. It basically says that you start with, and then another bunny, and then they get to like reproducing, or like then you have two bunnies. Anyway, it starts getting confusing after a while without actually going through the science of it. But do you guys see what the sequence is? These two make that one, and then those two make that one, and then those two make that one, and then the bunny dies. Well, we don't really talk about the death of the bunnies. There might be a question in homework that says, how do you show the pattern in a formula? But anyway, cool kids, you have enough to get started. Homework's due Friday. See you later.